Okay, guys, welcome everyone, and thank you for showing up to this very interesting topic and for dedicating your time to listen to our project. So, tonight I'm going to be talking about BDER, which is short for Blockchain Distributed Energy Resources. And we have some fancy definition for this with a lot of complicated words. Its description is a blockchain-powered software solution that maximizes the use of renewable energy in microgrids through algorithmic optimization. So this sounds complicated, but it's actually a very interesting and simple idea, which is like a logical level up to this current energy sector industry. So what is the problem? I'm going to start with the problem. So as we're all witnesses today, energy sources and energy utilization seems as a big problem, as we're witnessing through this war and throughout short history, where fossil fuels represent the main source of energy: coal, gas, oil. So this has two main negative effects. First, that it is limited in resources, and the second one, that it's very bad for the pollution of our environment. So the utilization of renewable energy becomes and represents itself as a logical level up. And we've seen implementation of renewable energy systems like wind generators and mostly solar panels. So this is something we've all seen before. But where is the problem? So the problem becomes when you want to implement that system into your private household. So there are, what is like the typical use of solar panel? So for example, we have a single household which has like single solar panel. So it's not just like that. It's not like you buy a solar panel, you connect it to your house, and then you have renewable energy. So every solar panel has its capabilities and limitations regarding to the power sources and the amount of power it can produce. We have a phenomenon in parts of the world where sunny days are available during most of the year. So, for example, I like to take example of the parts in Greece. So, what happens there is we have a lot of households that have a lot of solar panels, and this household, as an individual household, during daytime, during summer, produces more energy than it needs. So it has the surplus of energy. That's okay. Everything seems fine. This household is environmentally friendly. It doesn't use fossil fuel, and everything's okay. But when is the problem appearing? So during the night, this household doesn't produce any energy. So it needs to use its energy from the main or central grid from the city. So it needs to be connected to a central grid. What happens with the excess of energy during the daytime? So let's say that it has like 20% more energy than it needs during daytime. So this energy needs to be used or stored, or otherwise it would be wasted on heating those solar panels. So if this household wants to keep this energy, it needs to install like a storage battery to store all the excess energy and to use it during the night when there's no sun. These batteries are very expensive, and actually they're producing the process of producing these batteries is a very dirty process. So if we want to offer an environmentally friendly solution, massive use of battery is not going to work. But what if we connect another household and another one, which have, for example, this one has 2 solar panels. This one has 1 solar panel and 1 wind generator. So if they all rely on themselves, they're going to have the same problem as this one. But if we connect them, maybe this 20% of energy can be transferred to the first neighbor. And then, for example, this household has 10% more energy, during sunny but calm days in terms of wind, they can supply the third neighbor. During the night, maybe when it's windy, and those two households which have solar panels are not producing energy because it's cloudy and it's night, but it's windy, the third neighbor can actually supply them with energy. So we reduce the need for those storage batteries, and we start to form a microgrid. So this is like the core of this idea. This sounds perfectly simple in this whiteboard, you know, but there are some limitations. So the concept here, okay, the concept here is to form a three-layer ecosystem where we have a software which will act as a brain of this system. We'll have a microgrid of interconnected households, and we'll have the infrastructure between them. So wiring infrastructure and controller infrastructure. How it's going to work? So current use of microgrids and electrical distribution system, it doesn't work like this currently. So what are like big companies offering right now? The most what we see most often actually is that there are some types of microgrids, but with centralized and massive solar fields and wind generator fields. So, for example, they have the essential part of the city, which has hospitals and, for example, schools or some very important industrial objects, factories, for example. And like city itself, they have a huge solar panel part on one side of the city and huge wind generator part on the other one. And for example, they can have water power station in between. So what they actually provide is let me just, is there like the yes. So for example, what they try to do is that they try to disconnect this essential part of the city from the main grid, because there's a danger that if there's a disconnection happens previously in the main grid, that this essential part of the city will remain without electrical energy. So what they do is that they provide they form a microgrid inside the city to supply it with alternative energy sources. But this is not peer-to-peer. This is still centralized, where all those essential objects are connected to this like solar part or wind generator part of electrical grid. What we try to do here is to connect houses peer-to-peer directly. So where every household will be a generator and they will be a consumer. So they will act as an individual entity in this system. This also seems a little bit simpler on the whiteboard. So the first limitation that we have here is physical limitation, which is defined in physics as Kirchhoff law. So Kirchhoff law, this is, if I remember correctly, this is the first Kirchhoff law. So for example, let's say that we have something like this. Situation like this. Okay, we have first node, we have the second node. The idea here is to monitor the energy status of each household and to try to balance the energy, to try to make them automatically trade, so we can always have the same amount of energy that's being produced, that's being spent, and then it's being transported further away if we have excess energy. The problem here is that the electrical current is much faster than the blockchain, and it travels actually the speed of light, through the speed of light. So what Kirchhoff law defines here is that we have, for example, 5, 2, 1. So maybe you can guess what would be the current, actually, which is defined as with E, that will need to go through here. So we have input of 5, we have output of 2. Then we have actually 3 more here going to the node 2. We have 1 unit going through here, so 3 plus 1 are actually 4. This all happens instantaneously. If we want to make this work, we need to make this work instantaneously. If we wait for the blockchain to calculate everything, to put it on the smart contract, and then to execute transaction, this node will have, at a certain point in time, it will be out of electricity. So what we need to do is we need to define the period of time through which we measure the exchange of energy. So it's not going to be like instantaneous. We'll follow the period of time. So this is like in short what we plan to do, and we divided this through 3 layers. So layer 1 is the software, which we'll be focusing on today. Layer 2 is the hardware controllers. So those controllers that monitor the status of each household in a live scenario. They monitor the input of energy generating, amount of energy that's been generated, and the amount of energy that's been spent. And the third layer is actually infrastructure with microgrid devices, renewable energy devices. This is the logic. Okay. Layer 1 software. We actually have the secret sauce here, and it's being developed between Bloxico and Utrecht University in Netherlands. So this is the algorithm that takes care of all these laws, follow the optimal power flow, so they can transfer energy between each other with least amount of energy being spent in the process, and actually to calculate all the transactions and actually try to monetize that process. We implement blockchain on top of that and smart contract, and I think that you can guess where in the meantime. And we have a simple interface for the participants so they can track their energy status, savings, and where they are in this grid. In layer 2, hardware controllers. So every hardware controller needs to be a validator node. So validator node that will validate all the transactions on the blockchain needs to be installed on the controller. Communication between nodes and different types of controllers. So this is mainly like infrastructural limitation, which we're not going to be focusing today. We're going to be focusing on solution. So layer 2 has those controllers which act as nodes, and every household has its node. And layer 3 are microgrid devices which contain like different functionalities, or let's say like can be in different variants. So central grid connection on and off, coverage with renewable energy devices, and network capabilities and limitation, which is also infrastructural like limitation, which we'll cover shortly in this presentation, but I'm not going to be focusing a lot on today. So the main functionality, the main thing that defines the microgrid is that it's actually divided from the central grid. So if we see a central grid here in the city, it goes like this, and then it's connected to different parts like this. So we have some buildings here, building here, then households here. So everything is connected to the central grid. And how they measure if everything is working? So there is a frequency which we'll learn during the process, that this frequency is actually 50 hertz. So this is very like sensitive measurement, and they try to measure the frequency in this whole network, so they can see that everything is working perfectly. If you look at the grid of big cities, we see that they are actually a huge microgrid. Why? Because all the excess energy here that's being produced, more than it's consumed by the participants, by people that live in the city, needs to be stored somewhere, but they are not storing this huge amount of energy. They're actually exporting it to other countries or other cities. So if we zoom out, for example, if we see the Eastern Europe, we see Belgrade, we see different cities, we see Novi Sad, we see that they are all acting like a participant in this microgrid, and they are all connected. So if Novi Sad has excess of energy, they will transfer it to Belgrade. If Belgrade has access, they will transfer it to another city which has actually a less amount of energy than it needs. So the grid in a whole looks as a microgrid. We want to zoom in and to form that on a smaller scale, for example, 20 houses. The physics here is the same. So we'll have one connection from the central grid here somewhere, and then we'll have a couple of households. There are certain limitations. Why I'm explaining this? This shouldn't be important, but there are certain limitations throughout Europe. Some countries are more flexible than others, but some are not, for example, Serbia. There are certain limitations that define the transfer of energy, and they are very strict about it. So right now, how can you enter to serve the main grid and to save energy with renewable energy resources is if you're a private owner of a huge wind generator field or a huge solar panel field. Yeah. So this is very complicated process because it goes through like government contracts, confirmation by different government entities, and it's not really user friendly for the end user. But what if we have a single connection to the main grid, and from that point we perceive ourselves as a single household? So we are all living together in a hippie commune here, you know. And is it legal? Well, it's not illegal, but this is the way. So microgrids are divided totally from the main grid and connected only on a. I know. So they're being connected to the central grid with a single point, but they're being interconnected in between, like this. And this single connection to the central grid records all the like energy transfers between the main grid. The easiest way is if you only import electricity from the main grid. That's what we all do. You know, you turn on the lights, we import the energy. But if we want to give it back to the central grid, then we have a problem. Regulation. So this way street is okay. This is what's going to happen in most of the scenarios right now, realistically, if we are looking realistically. So there is not many, how do you say, settlements. There's not many settlements that are totally self-sustainable, that are totally self-sustainable and totally relying on renewable energy resources. But most of the time, what we're gonna see in real life is that for example during daytime, during summer, during windy days, they're gonna be in a slight excess of energy, and during night they will probably import energy from the central grid. So what we do here, on top of that, we put a smart contract. Smart contract is the brain that has this algorithm in it. When there are conditions that are defined in this algorithm, and I will forward you all through the group the link to this algorithm, which is very complicated, and I don't want to go into details about it, but it's based on ADMM algorithm. And you'll see in that work that we did with Utrecht University, when conditions are met according to that algorithm, the smart contract will say, okay, these conditions are okay for the transaction, and the transaction will begin between households. When there's a certain period of time that elapsed, we're gonna screenshot that and see, okay, in this like 1 hour, this household had 20% more energy than it needed. sent it here, then sent it here. This one imported energy from the middle one. This one had a little sole process of energy, and this one didn't have anything at all. So we pulled. We were in minus, for example, at the end of the process. We were lacking like 10% of the energy, and we imported that from the main grid. Consumed from the main grid. This is in accordance with Kirchhoff law that I mentioned at the beginning, because the sum of in and out. This is the first definition that we always need to. This is the first most important formula that needs to be filled all the time. Condition. And whenever, if we have a situation, for example, if we have a regulatory limitation to export the excess of energy to the central grid, then we'll need storage batteries. So only in this case we need storage batteries. If we compare the first solution that we are addressing now, right? Which is most common today, is that only one household which use renewable energy resources needs storage batteries. So it can be self-sufficient in most periods of time. Yes, Ned, please.
Just one question. I think it would help. One, two, three. It's actually just very quick. Yeah, one question. I think it would help to clarify. You have one condition, which is this formula, or condition sum to zero. What you need for the microgrid? You need connection between households for the electricity. So if there is no connection, you can't have it.
Of course.
Yeah, if I am there living and I am not connected,
you're not participating.
Wire, okay,
exactly.
The wire connection would be plus. If we want to talk about blockchain, we have to have some kind of internet. It could be the wire internet, it could be the Wi-Fi, it could be whatever.
LAN, exactly.
Yeah, without internet, there is no solution. So these are the other conditions, maybe to be clear for everybody, because it's not guaranteed that this one household will have internet. If you without internet, you can't participate.
Exactly.
That's basically the rule.
This is very important that Nenad mentioned. So this law and this condition is physical limitation and physical rule that we need to follow. But following the infrastructural and hardware rules is that those houses need to be interconnected with wiring infrastructure, with a cable, with a controller that monitors the energy status of each household, and that runs a node. Also with internet, so they can communicate between each other and update their status to the blockchain, so it can be tracked through a period of time. If any of these conditions is not fulfilled, this household, for example, is out of the game for the time being. So this is regarding the layer 1 or the software. So I think you understand where the blockchain and smart contract come in here. Why is it important? So many of there are some actually microgrid solutions that are run by like privately owned companies, and there is a survey that's being done actually from Utrecht University, and most of the participants actually said that they have privacy concerns and concerns regarding the spending and consuming and generating amounts of electricity that are being seen on their invoices at the end of the month. So they're actually having double thoughts if they should participate in this kind of microgrid. With blockchain implementation, even though it's run by a company or not, it's a decentralized system. You cannot the data that's on the blockchain. Blockchain is immutable by itself, so it cannot be changed. So you can always go to the blockchain and see what is the actual status of your household at any certain point in time. So this is the other benefit why blockchain is here, and it removes those double thoughts by the participants. And we are also in the process of making an interface that is very like user-friendly, where user, without knowing what kind of software is behind it and what kind of logic is, he can track how much energy he saved, how much energy he sent to the neighbor, how much he imported from the central grid. And why is this important? Because if you are having a self-sustainable household, you can actually earn money through exporting energy to your neighbors. The point here is, if you are, for example, any participants here, even though you're importing energy from your neighbors, you're still saving money, because that energy is still cheaper than the energy that's being produced by the central grid. Because this energy, even though it comes from your neighbor, it comes from renewable energy resources, which is cheaper. So either just participating here, or being an active participant which is producing energy, you will have a huge incentive to be part of this microgrid. I will focus shortly on layer 2, so hardware controllers. This is very important, since every controller will be running a node. This will be a validator node that will validate and follow the energy status of each household. This node, as Nenad said, needs to be connected to the internet and needs to be checked all the time if it's giving the right data. So this is as Marco and I talked today, very important to set the node in the right way and install it correctly, so it cannot be like changed by the owner of the house. So we can be sure at any given point in time that the data that's being recorded through the node is correct. So the network cannot be manipulated. Communication between nodes, as Nenad said, through internet or through LAN. So we can have like LAN connected inside the microgrid without connection to the internet. Without communication between nodes, there is actually no participating in the microgrid. Different type of controllers is actually a challenge, since there are different types of controllers in different countries in the world. So we have to adapt our solution to fit most different types of controllers, but this is not a huge challenge. And layer 3, microgrid devices, central grid connection on and off. So as I said, there are actually 2 self-sufficient microgrids in the world. But what we're going to see in like most often is that they will actually be not self-sustainable, and that they will need connection to the main grid. And I will stay a little bit on this, because there is another benefit of connecting to the central grid. So we learned through the process that balancing of energy is very important to the like central grid operators. Some countries that have good energy balancing, for example, Switzerland, benefit from this very well. For example, in Switzerland there is a lake. I forgot what's the name of that lake, that can like change the level of water. So, for example, if they have some country, neighbor country of Switzerland, has excess of energy, the Switzerland will buy that energy, import that energy, and use energy to bring the level of water up. So what they will do then, if they need energy, they will open the dam and let that water generate electricity through the dam and through hydropower station. So actually, when they offer service of importing energy or storing energy for somebody else, they are actually earning money there. So microgrids, when they reach certain scale, that they can actually have this passive income from central grid operators. And this is very important feature. We've seen through the research that bigger microgrids that have like 50 or 100 households inside of it can actually offer energy balancing functionality for the main grid operators, and they can actually earn from that. So the reason for that is that it's cheaper for the central grid operator to export the excess energy to the neighboring household than to export it to the Hungary, for example, or Switzerland. And this is why connection with central grid is very, very important. Coverage with renewable energy devices. So logically, the more renewable energy devices that we have here, the better. The participants that don't have any renewable energy devices here have some benefits with participation, but it's actually exponentially increased when they have more. So this is like self-explanatory, and I'm going to skip to the next point, and network capabilities and limitation. And this is strictly regarding physical limitations, as we mentioned here, regarding Kirchhoff law, and also regulatory limitations. But as most of the countries see the importance of using renewable energy resources and loosening up the regulatory window for regular user to join and to participate in some kind with renewable energy, they're seeing the benefit of that. A lot of countries actually changing their policies regarding those regulatory limitations. So we hope that, and we see that there's a good track record regarding this trend, and we think that it's going to still happen in the near future. So this is in short about our solution. The one important functionality of our algorithm, which we developed and which can be used as a standalone project, is OPF system. And this is the part of the algorithm that actually makes the difference here, since the OPF system, in accordance with ADMM algorithm, can be actually implemented on a larger scale. So it can be implemented in a whole city or on the whole grid of country. So OPF stands for optimal power flow, and effects of optimizing the power flow in a huge grids are exponentially increased, since the resistance is increased with the distance of the current that's being transported. So even though we are talking about alternating current in most of the grids, still the losses during the transportation are huge. So optimal power flow that is developed through our algorithm can be implemented on a microgrid itself or on a larger scale in a grid. So this is about be there, and I'm open to any questions, guys. Okay.
Thanks, Nicola. It was very nice of your side to explain this project. Here I can see name, it's green. What is if it is a green project that we assume and suppose, just give us which point of this project is based and why is the green project?
Okay. Well, the first reason is that, as we see here, is that we are using actually renewable energy resources. So this is the most important part of why is it actually green. The second reason is that we are removing or reducing the need for storage batteries. So we are balancing this energy between households, and we are not leaving a single household to rely only on itself. So we are reducing the need for storage batteries, as I said, that represents the part of the dirty industry to produce them, and using the renewable energy. So this is the biggest factor why is it actually green. On the other side, for the energy balancing, as a third benefit of this solution, is it's much more simpler for main grid operators to balance the energy through a separate entity than to reduce the amount of power that's being produced by the power plant, because when it actually reduces or changes the amount of energy that it's producing, that's very, very bad for the environment, and also not very energy efficient. So they want to keep for example, thermal power plant on a steady power production, and to balance any energy changes through different entities. So those are 3 benefits. Why is it green?
Thanks a lot.
Any other questions?
Okay, so in the long run, when we have like 1% of people are using your solution,
Okay.
but when it comes to like 20 or 30%, how does the government take their cut? I mean, that's a lot of resources that they will, a lot of customers that they will lose. Do you think it's, how do you see that happening?
Well, this is like a very tricky question, and there can be multiple answers to this. Government
Maybe later. Maybe
governments will support us in this solution. Just kidding. Okay, so as we're seeing, for example, now in Germany, and also in Serbia, so those countries are heavily relying on energy sources that are coming from different countries. So in this particular situation or moment in time, they should be supporting this solution, since the energy will be produced within the country, and they will lower their the amount of energy from other countries that they are relying on. So I see that governments will actually first limitation that I see is that they will recognize this as a solution, and they will recognize this as a standalone project that can be easily connected to the central grid without like any huge contracts. But your question, I think, comes after that. So let's see how they will react to this, since there's a lot of this is a huge trend in the industry, and there's in different countries there's popping up with similar ideas. So we'll see what the results will be.
Great presentation. First of all, what is the furthest distance between the households that has to be for the grid to be, for the connection to be made?
So of course, this is connected to when I was talking about like losses in the energy and optimal power flow. So for example, if we have a microgrid here, you know, with few households, and then we have like a separate household which is here. It's not the best idea, you know, to connect, and since a lot of energy will be wasted through the transportation process. So our first use case is going to be focused on settlements that are with households that are very near each other. So this is the beginning point. Neighbor countries. Yeah.
Thank you.
Yes, Nenad?
Yeah, thanks for the nice presentation, a nice smile,
Thank you, Nenad.
and a good style in dressing. Okay, my question is that solution, is it going to work if we disconnect the central grid? And what would be the challenge?
Yes. As I mentioned previously, this connection can be on and off. So central grid can act as an infinite energy to import the energy from and consume the energy, or as an infinite battery to store the battery then. But what if there is no connection with the central grid? So this is what we are seeing with actually military microgrids that are being formed right now. So all the trendy industry is being developed first in the military, and there needs to be different kind of energy sources that are supplying this microgrid. What they did actually, I forgot where it is, but it's a military microgrid that's been made. So there is a connection with the central grid, which is very unstable due to the different limitations. I forgot like which, but probably doesn't matter actually. But they cannot rely on the central grid. So beside renewable energy resources that they are using through wind or solars, they are using also different generators. So this is still green solution, and this microgrid settlement needs to be totally self-sustainable to be disconnected from the central grid. In other case, we will have like fluctuations in energy, and some households can be left without electricity. What we can do as I explained here, we can define what are the most important objects. So, for example, hospital and a factory. So they will have priority number 1 and priority number 2. And when there is not enough energy to supply the private households, then we'll make sure that only hospital and factory is supplied.
Is it possible to look for the next level of zero, sum zero, by excluding certain consumers on the network, and to look for this condition to be satisfied?
So, if I understood your question correctly, exactly that.
My question is that are we going to lose the whole microgrid just by losing 10% of the supply? Isn't that better to switch off to certain customers to say today, now you can't get the electricity?
Exactly. Maybe I didn't explain it clearly, but exactly that. So we can make a different status or importance of different objects that are participating in the microgrid. So we're going to cut this one off because it's a private household, or we can implement like the different restrictions during different period of time.
Yeah, my question is, if I'm this guy with number 1, and if I'm clever, I install some wind generator, so I don't want this solution to cut me off, so I cannot have an electricity, if you understand.
Of course.
So only deal with the surface or additional electricity I want.
That you want to import from.
Basically I want to sell it.
What you produce, it's yours. But this is your private. Those like devices are privately owned by you. So so classes, different like classes or importance of different objects are they need to be like implemented inside the microgrid. So this is one of the good explanations. For example, if we look at the like timeline of the day. So for example, this is like midnight, this is 6 a.m. This is midnight, and this is like let's say 6 p.m. Yes. Okay. So energy starts rising like this. So using of energy in the normal conditions. So right now it's like this. So we have like slight peak in the morning, and then we have like a higher peak in the evening. And what is great with solar panels is that it goes with the sun. So it acts like something like this. So it can actually cover both of those periods. And why do you have cheaper energy in certain hours? You know, like turning on washing machine in the night. So the reason for that is because huge factories and the huge users of energy are operating in these hours. So they want to motivate people to use devices outside of these peak hours. And this is when actually solar panels, for example, come in handy, because they cover this period of time. And throughout implementation of renewable energy sources, we can motivate them to use energy in different periods of time. So we can keep the balancing of the grid constantly.
Okay, I understand that if you're connected to the central grid, that would be your roof price. It means otherwise you will not want to buy from the neighbor.
Of course.
He is selling 2 times the price of the central grid.
Of course.
Okay. My question is, would you have a volatile energy price inside the there, or it will be fixed? And why would be fixed or volatile?
What's happening inside of the grid is that we are matching the supply and demand. So it's going to be like a basic market, but we'll have the information at a certain, actually throughout the process, we'll have the information about the price of the electricity from the central grid. So throughout implementation of renewable energy devices, as the production is cheaper and as transfers are actually on a shorter distance, the energy by itself should be lower cost. So there's no reason at this point in time to believe that energy imported from your neighbor will be more expensive than importing the energy from the central grid.
No, but it doesn't make sense because you would use the, you don't want to pay that price.
Of course, you will just use the energy from the central grid.
Exactly,
At that
that's my
moment.
point. But would you believe that this price during 1 hour, during the day, would vary, would be volatile or not?
The price of energy.
For example, if you have a lot of supply, so you will have one moment you actually have access of energy, and so that would be the cheapest.
I understand what
Once you start adding the central grid energy, the price will go up with the roof of central grid.
with the roof of central grid price. Exactly, that's the point. That's the point.
So I can see there, just like by thinking about it, that this would be the volatile price during the day. Not to be fixed price. Let's say central grid is €1 per kilowatt, and this price is 0.5.
And the peak price, the roof, would be the price of the central grid.
No,
energy.
but this would be
Exactly.
0.5, 0.6,
It will
0.7.
the price will actually change during the day,
Exactly.
depending on the supply and demand as a regular market.
Yeah, and then the fun comes if you don't have a central grid. It means the price could go to close to zero.
Or it can be very expensive.
Or it could be, but close to zero means you have more than anybody needs.
Exactly.
So it goes to almost
zero.
Almost zero.
Of course, if most of the
But if you
participants.
have a not sufficient supply, then it goes very expensive.
Very expensive.
If I want to watch something or add some refrigerating, I don't want to lose that kind of state.
Exactly. The central grid gives us security, both in energy-wise or price-wise. So if we have a self-sustainable microgrid that's disconnected from the central grid, yes, price can be very volatile. If it's self-sustainable with a lot of energy that it can actually export, yes, price will probably be zero at some point in time. Close to zero.
No price.
Thank you. Okay, any more questions, guys?
One more, I guess.
Okay, and there's another one also.
Focusing on that so-called micro community over there, I doubt there is some viable research done yet. So, just hypothetically, in case that one household from the whole grid for some reason creates a superset of energy. For example, they take a vacation in Spain for 3 months, so they constantly use solar panels, wind turbines, whatever, create a superset of energy. Is there, since there's the blockchain on top of that controlling the input output and all the immutable data going in and out, what would you personally decide to take as a reward in this particular case? Some sort of token, some sort of reward that you can use in whichever manner you like, or just have it been collected as a data on blockchain that you have debt. Actually, the others have a debt in kilowatts towards you, so you can use basically free energy from the other sources from the microgrid for some period of time.
That's a great question, and there are a few answers to that question. So first one is the answer that our solution is focused on, is that through this interface, and I will provide info about that in the group. Interface for single participants has a wallet connection possibility. So you connect your wallet, and you can actually you need to put funds on that wallet. For example, if you are mostly importing energy from your neighbors, supply and demand will define the price as Nenad asked, and you will pay for the energy you're importing from your neighbor. And on the other side, your neighbor will be rewarded with these tokens. So this is one solution to that question. Other solution is to import green credits or carbon credits, and to have a parallel to that. But this probably needs to be in arrangement. We'll see probably in future that 2 or 3 solutions are appearing, and we'll probably see in the future that needs to be done with a partnership with different carbon credits companies. So you can actually have a debt in a different way. But yes, to have a successful transaction, you need to be rewarded with something if you're exporting energy.
So basically, you got it covered.
Sorry,
you got it covered. The both scenarios. The participants have the choice of the way they will be rewarded in the end.
Right now, we are focusing on a token. So we are developing on an EVM-compatible blockchain, and we want that transaction to be done in stable coins, since we don't want the price of energy to be volatile, because the price of energy will be changed during time. So and also if the price of the token is volatile, so what can you count on during those transactions? You never know how much you paid actually. But we want to implement stable coins, and those stable coins will be the funding for settlement in these situations. But the other ideas are those carbon credits, green credits, and stuff like that.
Got it. Thank you.
Thank you.
Hello, thanks Nicola for the presentation. I'm actually coming from the energy sector, and this is really interesting for me. It's a great solution, and I was thinking about how to implement blockchain in those microgrids and actually usage of renewable energy in small producers like households. Just first some background, maybe information from the energy sector. So all those connected that have production of energy from renewables are called prosumers. So they are at the same time producing but also consuming energy. So they are prosumers, and in Serbia, for example, they are recognized since 2021, when you can become a prosumer as a household or a homeowner association or some other prosumer, which can be a private sector or a farm or what else. So a prosumer is someone who is at the same time producing but also consuming energy. And here your actually presentation is covering them actually. So the connection to the grid, when I'm thinking about what are the possibilities here in Serbia, for example, you can be, if you have one connection point, you need to be a prosumer, because the other option is to be a producer. So you are not a producer of energy here, because you also would consume some energy from the grid. So I'm really interested to see how advanced are you with your solution in actually implementing and maybe testing, piloting this in a real situation, because as we heard on the beginning, we need some infrastructure development here.
Exactly.
Besides the regular equipment that you have, for example, with solar PV, with panels and inverter and a two-way meter. If you're connected directly to the grid here, maybe you won't need that, but you need those controllers that you're mentioning.
Yes.
And connection to the internet or a LAN. So how advanced is your solution in piloting, for example, something like that in a real world?
So right now we developed the software, and we are in development of the controller hardware with a few potential partners from the energy sector. So we want to simulate. So we want to cover those two things: software with the blockchain implemented, with algorithm, with trading capabilities, and also the hardware controller that will track the balance of those prosumers. So this is our main focus right now. And after that, we want to simulate the behavior of a simulated microgrid settlement. So right now that is the status of the project. So yes, we actually partnered with Institute Mihailo Pupin. So they are helping us with also regulations, explaining to us regulations in physical world, and also that are governing the law of grid, and also with hardware controllers.
So the first kind of pilot or proof of concept on physical microgrid is planned to be on the Mikhailo Pupin
Exactly, with
microgrid devices. Yeah, sorry, I'm just kind of trying to help because I'm also involved by not disturbing you too much. Okay. So I mean, I'm proud to announce that Bloxico is partnering with Institute Mihailo Pupin, and the reason is that they declare they have 80% of the network of the electricity in Serbia, covering with their devices as well. They do have controllers, although these controllers are kind of with a different application or usage with the SCADA systems. And interestingly enough, before we talked to them, they had in plan to do the microgrid with a centralized SCADA solution. And they were actually surprised when we draw this diagram, where actually we took 70% from the diagram just by doing the blockchain solution. And also one thing I want to add is the value of usage for blockchain here is interesting because it could be solved with other peer-to-peer solutions. And the beauty of blockchain is maturity, although we talk often about immaturity of blockchain.
Yes.
And blockchain here is a very nice framework that you can do peer-to-peer system, and you can implement some kind of tokenization and all this stuff. Otherwise, we would never even try it because it would mean at least 24 months of 100 people developing some kind of peer-to-peer solution, which would be that would be like a deal breaker.
Thank you, Ned. Yeah.
And no trust, yes, sure. It will be, we have trust issue because we don't have this developed for sure.
Exactly. Okay. Thank you, guys. Thank you. Hvala svima, društvo.